Hello everyone. I'm Andy from ThinkMo. I'm currently teaching CCIE courses. From today, I'll share some with you. Technology related to CCNA, CCNP, and CCIE. Our topic today is: how does the router query the routing table? We mainly based on three aspects to query the routing table. The first is the longest mask matching principle. The second is the priority of the route. The third is the value of cost. We usually call it overhead. It's in a link. According to internal calculation criteria, different routing protocols, it has a different internal algorithm. Why is it called overhead? You can think of it as cost. Let's say how much I spend on things. Which one is cheaper? That's roughly the idea. The cheaper the better, surely. For the value of cost that we talked about. The smaller, the better. So let's start with the first one. Is the matching principle of the longest mask. So what does the matching rule mean? So it's based on the mask length. So first of all, of course, there are preconditions. It has to match. Take for example. First, my target network is 192.168.1.1. So let's see. This route A and this route B. This route is 192.168.1.0. It is a 24-bit mask. It is 0 to 254 of these IP addresses available. So it's in segment 1.0. The first IP address represents a network segment. That's the concept of network numbers. That was the last IP address. Like 1.255 represents the broadcast address. How can we not say too much here? Like the second segment. 1.030. It's a range of values. This is 192.168.1.1 to 192.168.1.2. These two are available. It also represents the 1.0 network segment. It's just that the length of the mask is different. So routes A and B both can match 192.168.1.1. The target IP. Of course. We can also put 192.168.1.1 as a host. And then there's another route in the back. The route is 192.168.1.4. And then we have the mask of PI over 30. So in the process, the 1.430 bits involved don't match. Because this is the segment 192.168.1.4. Prove that there are two addresses available. So if you still don't understand, we can say that it starts and ends at 1.4 to 192.168.1.7. So 1.4 of them don't work. 1.4 represents the network number. This is the route. You can think of it this way. 1.7 is a broadcast address for segment 1.4. So what's really available is 192.168.1.5. 192.168.1.6 indicates the two IP addresses. Obviously 1.5 and 1.6 do not include 1.1. I'm going to prove that this one doesn't match. So we have to choose between A and B. So I'm definitely going to choose 30. Why is it smaller inside? We usually say the longer the mask. It means more accurate. So choose route B. This is called the matching principle of the longest mask. So there are two things to watch out for. The first one is that it has to match. The second one is in the case of a match. According to the longest mask matching rule, select the route with the long mask. The second aspect is the basis. The priority of the route is compared. So different routing protocols. It corresponds to a different priority. So that's the priority. In Cisco it's called managed distance. So the first one is direct connection. The direct route is 0. OSPF is 10 in Huawei. ISASIS classified into Level 1 and Level 2. They are 15 and 18. Static is static, which is 60. RIP yes 100. And other priorities. The smaller the priority, the better. For example, a direct link and an OSPF link. That's 0 and 10. Of course, the prerequisite still has to match. At this time, direct connection will be chosen. Obviously. If at ISOSPF and ISIS, I would choose OSPF because it has the lowest priority. The third aspect is cost value. The value of cost varies by protocol. It goes through an internal algorithm. We've already talked about this. For example, something like OSPF. It's an algorithm that uses SPF. It's the tree algorithm. Then it needs to refer to different algorithms. Refer to different standards. There are some formulas for calculating it. Like OSPF, it is mainly reference bandwidth. RIP is the reference hop count. In terms of the number of hops, it's easier. Like how many jumps I've taken. It doesn't look at the bandwidth. It was designed in the early days. There are certain defects. Don't look at the bandwidth, look at the hop count. This is pretty obvious. Just for example, I went from Shanghai to Beijing. There are 5 routers. And in the process, I'm the first path. The second path has 2 routers. But the bandwidth between the 2 routers may only be 10 megabits. And the bandwidth of 5 routers. It could be a GE. If selected according to RIP, it will choose this line between 2 routers. And for OSPF, what bandwidth is it going to choose? Because it mainly refers to bandwidth. Let there be no misunderstanding here. The cost value is usually in the same protocol. For example, OSPF is the comparison between OSPF and OSPF. Let's say a path. OSPF calculated the value to be 10. That's the first path. The value of the second OSPF path is 20. At that point, I would choose 10. According to what we just mentioned, the cheaper the better. It's the equivalent of OSPF. Both paths can reach the target network. I'm definitely going to choose the lower the cost. So in terms of what we're talking about, the router queries the routing table. According to these 3 aspects, it goes from the top to the bottom. For example, first of all, the longest mask matching principle. Let's say the mask is the same length. A and B are both roots of 24. Now let's look at the priority of the root. Of course, you might have noticed that before. It is usually a comparison between different routing protocols. This is something you need to be aware of. Of course, there are special circumstances. For example, internal priority and external priority. We won't talk about that here. The third aspect is mainly for the agreement. The cost is going to go from the top to the bottom. That's it for today. If there are any other skills you'd like to learn, feel free to leave a message or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.